All right, guys. This is all I want you to know about Snell's law. It quantifies the physics of refraction. That's it. I know it talks about sine, and we already, some of us already took calculus and pre-calculus where we're using the T185 and doing sine and cosine, right? Mm-hmm. I just want you to know that Snell's law is related to the physics of refraction. That's it. They're not going to ask you to work on no math on there. All righty? This is all I want you to know. Snell's law is related to the physics of refraction. But I also want you to recognize that when you see it too. Recognize that. So if you see a sine, you know that's pertaining to Snell's law. I'm not even going to get into that page because this is all I want you to know. It's related to the this on this one slide. That's all I want you to know about Snell's law, basically. Okay. I know it has a big long explanation about the sine, what that means, whatnot. I don't want you to know that. I want you to know Snell's law is associated with the physics of refraction. Okay. Because we're gonna be talking about a whole bunch of laws. So I don't want to overcomplicate that. When we get the Ohm's law, we talking about Bernoulli's principle. You know, we're talking about what is I equals B times R? That's something we're gonna get to. That's somebody else's law. I just want you to know what those laws are associated with. Okay.
So we don't have to look. All this medium one, medium two.
Yeah, we're gonna get to that. We're gonna get to that.
Oh, they just come.
But when it comes to just Snell's law, I want you to know, because remember, Snell's law is related to that. It's all about refraction. Okay? So, you need to know that medium one is the medium where sound is currently traveling, of course, right? Of course. I mean, I almost feel like I didn't have to put the slide up there, but if I did, I want you to know medium one is always pertaining to the incident beam, right? Mm-hmm. Right? Because that's where sound is currently traveling right now. That's going to be our incident beam, right? Medium two is where sound is entering. That's going to be where our beam is going to be transmitted, right? So we have right here our air. That's medium one, correct? Mm-hmm. This water. That's medium two. Got me? Mm-hmm. Good. Sound is traveling from medium one to medium two. Transmission, incident. Golden, retrieval.
And speed, more? The speed.
What about the speed? I'm about to explain. You talking about right here on your book?
You have number in the picture. You have 330.
I was just showing you the difference between what's the difference in air and the difference in water as their propagation speed is concerned. That's all I was showing you right there. I wanted you to know the number because a lot of you guys may have forgotten those exact speeds, right? I'm sure you don't remember all those speeds on that chart. So I would just give you why why that refraction occurred is because of the oblique incidence and because the difference in the propagation speed between those two media, air and water. I was just giving you how fast sound travels through air, how fast sound travels through water. All right, heavy in the game. All right, guys. Again, Snell's law. What is Snell's law related to? Physics of refraction, guys. That's all I want you to know about that. You got a question, Lauren?
No.
You sure? I see your pen going. All right. So, again, we already know this. Our transmission angle equals our incident angle, right? If those mediums have the same propagation speed, correct? We're going to get this straight line. We're going to get this straight line right there, right? Okay. So refraction will not occur when the speeds of the two media are identical. The angles of incidence and transmission will be equal, and the beam will travel straight ahead. It's going to transmit straight ahead. Okay. Golden, again, right here.
What's an example?
Huh? Going from soft tissue to soft tissue at an oblique incidence. Me looking from the liver to the kidney at oblique incidence. It's not going to be displaced. Okay? It's not going to be displaced. Okay? Remember I was talking about the needle when I'm doing a biopsy? Sometimes that needle may be refracted because I'm watching it come in from the skin layer to the fat layer to the muscle layer to the soft tissue. Watching it go through all of those different layers of tissue, it appears to be refracted. It appears that it's not traveling in a straight line. Okay? That would be.
Is it the same as mirroring refraction or mirroring ultrasound? I don't know.
Mirroring Yeah. Oh, you're talking about like mirroring artifact? That's a form of refraction. Yes, it is. Absolutely. That happens with X-rays too, right? Absolutely. So again, if the two medium speeds are the same, guys, we're still talking about oblique incidence, right? If the two mediums are the same, have the same propagation speeds, we're not going to get refraction. It's going to travel straight through. Perfect transmission. All right? But if our transmission angle is greater than our incident angle, when the speed of medium 2 is greater than our speed of medium 1, remember, medium 1, what's that? Our incident angle, right? Medium 2, that's our transmission angle, right? The transmission angle will be greater than the incident angle. Okay? I know all of how the book explains that. Guys, listen to me. The easiest way to remember this is, easiest way, whichever medium has the faster speed will have the greater angle. Okay? Whichever medium has the fastest speed will have the greater angle. Okay? So, our transmission angle is greater than our incident angle, of course. That means our transmission medium 2 is greater than our incident medium 1. So this angle is going to be greater. See how much this angle is right here? Remember, we have to draw an imaginary line when it connects. So this angle right here is smaller than this transmitted angle because medium 2 is traveling at a faster speed. Again, guys, whatever medium it has the fastest propagation speed, it's also going to create the greatest angle. Okay, that's my look. That's
propagation speed has something to do with the density of the medium.
Density. What is it? Propagation speed equals the wavelength times frequency, or the density times density times frequency. Density times wavelength, I believe. Density times wavelength, I believe.
So, what were you talking about?
I'm just talking about the angle of refraction. That's all. I'm talking about the angle of refraction. I'm not talking.
I'm hearing speed of the medium.
Yeah, because that's what's going to create. That's the difference. We already know remember to have refraction, we need two qualifications. Oblique incidence, we already have that, right? We already hitting the barrier at oblique incidence. But we're determining whether the angle of refraction is going to be greater, less than, or equal to. Okay? Remember we said, if the speed between these two mediums, look, they have the same speeds, the transmission is going to be perfectly through at the same angle. Okay?
Different speed is gonna be different angle.
Yes. Now I'm telling you, now I'm explaining, is the angle going to be greater than the incident angle or less than the incident angle? Okay? Again, whichever medium 1 or medium 2, whichever one has the fastest propagation speed, that's going to create the greater angle. Okay? Again, transmission angle is greater than the incident angle. Medium 2 is traveling faster than, it's traveling faster than medium 1. Right here. Look, medium 2 the speed of medium 2 is greater than the speed of medium 1. The transmission angle will be greater than the incident angle. I'm trying to tell you guys an easy way to learn those. Okay? I'm just trying to tell you guys the easiest way. Whichever medium has the fastest propagation speed will also have the greater angle.
So,
the angle of incident is with the horizontal line?
Absolutely. Of course, we're making it into a graph. This is our medium right here. This thick black line right there. That's our medium. These are the same pictures you guys have in the book, right? On figure 623. Figure 623.
But we said earlier we do it with the vertical line. When reflection and incident. And
We're talking about transmission. We're not even talking about reflection anymore.
Oh.
Remember, we can't predict reflection with oblique incidence. It's too complex. Remember I said that, it's too complex. We can't predict that. We're talking right now about transmission with oblique incidence, which is also known as transmission with a bend, which is also known as refraction. Okay? We're talking about transmission right now. Boom, transmission. We're not talking about reflection anymore. Okay?
Oh, yeah.
All right? We're good there, guys? That's why I'm telling you, that's why I'm being so specific.
It could be vice versa, like if the incident of the angle, which is, this is the traveling, the speed of traveling, it's higher.
I'm coming to that for the next slide.
Oh,
That's the next slide. Give me a second. First, I'm just telling you guys the easiest way to remember that. Whichever medium has the fastest propagation speed will create the greater angle. All right? All right? So, again, medium 2, which is our transmission medium, our transmission angle, is traveling faster than medium 1. Therefore, our transmission angle, right here, it's our transmitted side, because that says incident. This says T, transmission, incident. Transmission angle is greater than the incident angle.
That's not the same as whenever you say that the one with the greater speed is the one.
That's exactly the same. Speed of medium 2, which is our transmitted side, right? That's our transmission. It's medium 2, right? Remember, it's going from 1 to 2. Correct. So that's going to be medium 2, right?
So can I go from from 2 to 1?
No, it can't, because it can't go from transmission to incident.
No, it's because you said at first. Never mind. I'll ask later.
Go ahead.
At first you say. Let me get my question first.
Okay, get your question together. Just the opposite way, guys. Just the opposite way as well. When the transmission angle is less than, guys, please know those signs, less than and greater than, please. When the transmission angle is less than the incident angle, that's because the speed of medium 2 is less speed than the speed of medium 1.
Right.
Okay? Just the same principle I'm telling you guys.
It's a greater.
Whichever medium is traveling the fastest will create the greater angle.
Okay. You answered my question.
The invisible question.
Okay. Then the transmission angle will be less than the incident angle. Here we have our incident angle right here. Somebody have a protractor? Nobody have a protractor so we can. You have a protractor for real?
This one work?
Man, I need the arch.
Oh.
I need the arch, Dewey. I need the arch
This is my
protractor.
home.
Yeah, I don't know where you got that from. That's that SI protractor right there.
I don't know.
All right. Again, guys, easiest way to remember that. What's the easiest way, Win? What's the easiest way to remember what's medium 1 or medium 2 is gonna have the greatest angle?
Faster speed, greater angle.
Bang, bang, just like that, guys. That's all I want you to remember. I know it has a lot of words to that. I'm telling you the way I remember it, the easiest way. Whichever medium is traveling the fastest will have the greatest angle.
so are you going to give a picture or a number of degree? How?
I may give a pitch. I don't know.
Oh, yeah.
You never know.
Yeah.
You never know how I get down.
So you're
I
going
don't
to
even know.
give an angle number, like a degree?
I could give you a picture.
Put a bigger picture.
Maybe both.
Alrighty. Again, here we go again, guys. This is all our pictures side by side by side. Alright. The medium 2, which our transmission, is traveling slower than medium 1.
It's great.
Okay. That means our incident angle is going to be greater than the transmitted angle, right? Right?
Yep.
Okay. If they're traveling at the same speed, they're gonna refract. It's gonna transmit in a straight line. No refraction will occur. No refraction will occur if they're traveling at the same speed. Okay. If medium 2 is traveling faster, meaning our let's say this side is air, this side is water, because water travels a lot faster, right? Right. So medium 2 is traveling faster. That means the angle of refraction is going to be a lot greater than medium 1. Okay. Boom. There it is on the chart for you guys, like in the book. All right. Speed 2 equals speed 1. No refraction. The transmission angle equals the incident angle. Okay. If speed 2 is greater, our transmission is greater than our incident angle. Our transmission speed, medium 2 is traveling faster than medium 1. Then the transmission angle will be greater than the incident angle. Okay. If speed 2 is traveling less than speed 1, okay, meaning our medium in 2 is water, our medium in 1 is air. I'm sorry, just the opposite. Our medium in 2 is air, our medium in 1 is water. The transmission angle will be less than the incident angle. Golden?
Not golden.
Not golden? I can't simplify it any
No,
more than
no,
that.
this is up to you, but I wanted to figure out medium 1 and medium 2. Okay. Here you said it says the sound is entering.
Mhm.
And then the medium 1 is saying the sound is
It's
currently traveling.
It's traveling from
So,
medium 1 to medium 2.
so if you go back to the picture, can I see one? Yeah, this one. So, who's entering is this side.
Incident. The I is telling you what's
Oh,
entering. That's
okay.
I.
Mhm.
That's medium 1. Incident. That's our starting point. Our
But that's
start-
saying traveling.
Yeah, it's traveling from this medium
Uh-huh.
to this is our barrier between two mediums right here to this medium.
Okay. I got it.
So it's even your pictures in the book are a lot better. It's telling you medium 1, medium 2. I took similar pictures.
Yes.
All right. So this is our summary of reflection, transmission, and refraction, guys. Again, reflection with normal incidence, it all depends on impedance differences, right? Okay? The resistance that sound has to traveling in that medium. Impedance right there. Okay? Reflection with oblique incidence, we can't predict. It's too complex. Right, Sophie? Reflection with oblique incidence, we can't predict it. It's too complex. We're talking about transmission. Every time we're talking about transmission, we're always talking about the law of conservation of energy. Okay? Energy is neither destroyed nor made. All right? Okay? And we're talking about refraction, we're talking about oblique incidence and different speeds are required for refraction. Okay? Refraction is transmission, correct? It's a form of transmission. It's transmission with a bend. Right, Farnaz? Okay. So let's do a little quick review over everything we talk about this chapter, guys. So again, transmission, that means our incident beam is gonna transmit to medium 2, to the second medium, right? When we talk about reflection, that's our incident beam is gonna hit a boundary. Some of that energy is gonna reflect back in the same direction into which it came.
Or the specular.
In that case, yeah, that would be specular reflection because our barrier is smooth. Okay, I don't always want you guys to think that all the images I've shown today have been specular reflection. Okay, because the barrier is smooth, just for illustration purposes. All right. So reflection is our incident sound beam hits a barrier, and then some of that intensity will reflect back towards the direction of the transducer, okay? In the same direction from which it came. All right. Refraction, that occurs when we hit a structure or a boundary with oblique incidence, and the propagation speed between medium 1, medium 2 are different. We're going to get refraction. Okay. We're going to get that bend, transmission with a bend, okay? Or that change of direction of sound. All right. Talk about absorption.
Absorption.
Exactly what absorbing is. Isn't absorption the greatest part? Oh man.
AD.
Oh, I took that from somebody else. That wasn't me right there. So we talk about absorption. We're talking about that's the greatest factor between the processes of attenuation, right? Most of absorption occurs the most. It occurs more than reflection. It occurs more than scattering. And then we have scattering, guys. That's when our sound beam hits the structure and it goes in many directions. All right. Do I have questions, guys?
What's the difference between transmission